for our branch here in Cambridge. And today we're going to be talking about the Great Escape, so looking at minimizing the impact of water leakages, gas escapes, and electricity strikes using spatial data. If you have any questions going through the webinar, you'll see in your little go to webinar kind of attendees box a little hand. If you want to click on that hand, it's almost like raising your hand in the class, and we'll come to you at the end. There's also you may be able to see a questions tab in that little box on the for me on the left hand side of my screen. If you want to write a question in there, we'll come to that at the end as well. So a little bit about Spatial. Spatial is a data solutions provider with its headquarters based in Cambridge, UK. Although we do have offices around the world, over in Paris, Liège in Belgium, Washington in the States, Sydney in Australia, and Dublin in Ireland. So we're a global data solutions provider. We've got some big name technology partners. So obviously, we're dealing in the world of geospatial. Esri is not a name that it's always far off the tongue when you talk about geospatial. And Oracle, a leading database provider. We're also third-party software vendors for Safe Software and their product FME, and what has now been rebranded to Vertigis and their product GeoCortex. Our key kind of focuses for where we offer our solutions, but by far not the only areas that we offer solutions to, is government, utilities, where I sit, and transport. And there's a list of several of our customers below there. So got some big names in there, like the likes of Ordnance Survey, Network Rail, and the US Census Bureau. So what are our capabilities as a spatial data solutions provider? Well, we specialize in your data landscape. So one of the key things for any data landscape is the validity of that data. So we have a product that we will talk about in a bit that kind of sits at the core of most of our solutions, which is a rules-based engine that kind of interrogates data for non-conformities and flags them to the kind of the data owner. We try and do this in a completely automatic way to try and reduce the need for manual inspections, because they are often time-consuming and costly. And we always work collaboratively with the stakeholders to make sure that a data quality level that is deemed suitable for them is reflected in that data set through validation. But validation is only half the picture, of course. You can flag the issues, but the real kind of crux of the beauty of geospatial is that data that you are making decisions off is correct. And like with validation, we have an ethos here that we try and automate this, again working collaboratively with the stakeholders to make sure that their data holding is something that can be trusted, is timely and relevant for the operational decisions that are being made. And then there's enhancement. So once you've got a data set within your estate, that is always is, but a increased value and an excellent source of decision making. There's further value that we can drive through that now. So data enhancements is really where our solutions, like the loss of product one we'll talk about today, kind of drive home and say, yes, you've got a good holding of your spatial data. However, now let's kind of build value on it and really draw out some efficiencies from the kind of quality and the accuracy of that data. Particularly in the utility space in the modern era, in the UK at least, utilities are being asked to do twice as much, but given half as many resources to be able to achieve that. So it's critical for them that they find the efficiencies wherever they can. And this may be through kind of integration of multiple data sources. There may be data silos across your data estate, sitting in different repositories, that actually if you brought the two together and conflated them, you may be able to kind of determine or abstract through analysis some added value or enable better decision making. It could be to do with inference, so missing assets, For the water sector, and I think also the gas and electricity sector, they certainly have to report on the length of pipes or the amount of pipes or cable that they're dealing with. And if we're missing that in the geospatial model, it may actually come as a cost to the business because they're not getting the subsidies that they perhaps should do. And of course, transformation. There are many different data holdings and databases and kind of data sources around the globe. Sometimes it's difficult to bring them together and conflate them into a single source of the truth. So we look at how we can take data from multiple different sources and kind of really reflect that in a single source, allowing decision holders and operational processes to run accurately and as efficiently as possible. So the problem here today, we're looking at the great escape. So in the particularly in the UK utility industry, loss of product is a utility-wide issue. All industries have, whether it's just through time, it's accidental damage, have a loss of product event every year. Managing these are critical. Utilities are trusted with the commodity that they own, whether it be water, gas, electricity, or the communications sector. So it's critical for their business processes and their kind of public appearance that they are seen to be managing that in the most capable and accurate way. The impact of a loss of supply event, they're rather varied, but the consequences can be upwards of severe. The most common one that you hear about mostly in the papers, and certainly you just need to go on the kind of the regulator for the UK Ofgem and Ofwat websites to see the financial costs that sometimes imposed upon utilities. But there's also a social aspect. People don't like losing, let's say, electricity to their home, or that they're unable to cook their dinner because they haven't got gas. And that can have quite a severe social impact on the appearance of the utility. And bad media coverage can affect kind of the social appearance of the utility themselves. The regulator, so there is, obviously we spoke about financial, but there are other impacts that the regulator can enforce upon the utilities, such as price controls, though these are closely tied to financial, but it's also telling the utilities that you need to become more efficient with the resources you have. As I mentioned before, particularly in the UK, utilities are being asked to do twice as much for half as much subsidies or financial support. So it's critical that they actually find efficiencies within their current resource base to find them. Operational, no one likes doing duplicate work. If we can make sure that the information that's being provided to decision makers and the decisions that they are making are accurate and timely, it could help improve efficiencies of operational processes. Environmental one, increasingly coming more kind of key and to the kind of front page. The environment is a big topic at the moment. So a loss of product event that impacts the environment, whether it be the actual kind of natural landscape or the species that live within that area, particularly in protected sites or protected zones, can have quite severe impacts. And dangerous. Gas in particular has a harmful substance and has an explosive nature. So you would like to avoid that when possible. The one that we'll be concentrating on today, and we've been collaborating with a number of water utilities, is leakage, so water leakage. And as I mentioned at the beginning, we're spatial data experts. So no matter the issue, we believe that the core of the information at the center of all these decision-making tools has to be relevant and accurate to the process or the solution that's being implemented. All utilities we've worked with, and we've worked with the vast majority across the UK, have a digital representation of their network. They do this because managing the physical network over what is often quite vast expanses of land can be extremely difficult without kind of that digital representation. And how they visualize it is inside a GIS. So we, as spatial data experts, try and keep ourselves as platform and data agnostic as possible. So we can work with any utility regardless of how they visualize or how they're storing that kind of spatial information. It also enables kind of real-time analytics of your network. So having this visualization, presenting the spatial data in a manner to desktop analysts who can then make operational decisions off what they're seeing in the map, which ties it crucially back into the accuracy of that information. If what the individual is being presented is wrong, they are making a decision to the best of their ability, and they're not to blame for that. However, the decision they could be making could be slightly skewed from what is actually represented in the physical world, which can have consequences further down the line operationally for field users. So what have we tried to bring to the area? So we kind of assessed what was happening in leakage, and we looked around at kind of the other technologies that are already in the space, as it's been an issue for several years now. And we've tried to say, okay, so let's bring it back to the basics. Let's look at a focus on data. So let's use the rules-based approach that we've kind of engineered here, work collaboratively with the utility subject experts, and come up with some sort of way of having weighted factors against kind of indicators of leakage. And then we've scored them. So depending on what kind of individual factor is happening, they will get a score, and it's all kind of conflated together, and then an asset is given an overall propensity score, which the idea is that when a user goes out, or when he's making a decision of where to go out, instead of kind of having to blanket or canvas an area of several pipes or so where we think there's an issue in this area, it gives them more of a kind of an analytical tool in the field, which in real time, that allows kind of investigatory teams to say, right, I suggest based off what is known in past events, we start here. And hopefully that will reduce the time it takes for investigation teams to actually detect where the issue is, and allowing them to kind of tackle the problem early on. It's also a way of connecting your desktop workers and your field force. So in the utilities that we've worked with, sometimes the kind of desktop analysts and the field users can be a little bit disconnected. And there's a vast expanse of knowledge that both sets of kind of users have, that is from a kind of a mutual standing where you sit in the middle. It's really kind of mind-boggling why isn't this being connected? Why isn't there collaboration going on between these teams? Because it can really enhance the efficiency. So enabling this solution, or through the solution, it kind of enables desktop users to work with field users in near real time, so they're able to make kind of split decisions that is fully informed, and they can tackle the problem early on, reducing the overall loss of product and the impact that loss of product can have on those kind of 6 impacts we mentioned before. And for the utility, you save time, so less time with your field investigators in the field, which kind of adds into the saving of money. So you're not having those resources tied up in that particular investigation for an unnecessary amount of time, and it limits the loss of that product. Again, minimizing the social, environmental, and financial impacts that the utility may have to incur should it be left unchecked, or they were unable to detect it in a timely fashion. So what are the advantages of our approach? So going back to our kind of core values, validate, correct, and enhance, the information that you base these decisions off has to be accurate. So it's crucial that they are validated and corrected to the standard that the data owners of the industry expect. Making decisions off poor data will lead to poor decisions. It's automated. So there is less, as I mentioned before, the efficiencies that we're looking for, there is less need to tie up valuable resources in doing manual operations. You can have these resources going out, adding further value, either the same or other areas, while this process is taking care of itself. It's completely repeatable and traceable, so you can run this process at any time that you see fit, or at a regular scheduled nightly schedule, or a weekend schedule, or whatever you deem fit. It's encoding knowledge. So from the field engineers that I've met, their knowledge of their kind of patch of network is invaluable. They know it almost off by heart. So it's capturing that knowledge and kind of bringing that in-house through code and then sticking it into our rules engine where it can be used for kind of future analysis and really enhance the process. Because say, for example, one of these engineers wins the lottery and decides to move to Spain, that knowledge is instantly lost. And it's difficult for the next engineer to come in and kind of capture that information. It's targeted. So we're trying to take our kind of point solutions. We're trying to say, okay, we're not offering a solution that does everything. It is a targeted leakage solution. So it is dedicated to helping you reduce your leakage. It's a leakage, but it also can help you determine flow rates, but also do several other operations at the same time. In our experience, sometimes the process can get slightly messy and the results you get out can be confusing. So we tried to simplify it to say, right, this is a business process, let's target it, we're here, concentrate on one thing, and let's get it right first time. It's evidence-based, so working collaboratively with other utilities, they've informed us that these are the classical factors that attribute to a leakage event. So we've gathered that information and tried to kind of bring it all under one process, if you like, to try and determine a more efficient way of working. And in that, it's effective collaboration. So working with multiple utilities and maybe expanding beyond, though this example is focusing on water leakage, expanding beyond water leakage to try and bring in factors that may affect others, so electricity and gas being a focal point. And the benefits. So there is a massive reduction in cost. You're not sending lots of field teams out to kind of scope out a DMA to try and find where this leakage is as quickly as possible. You have a very targeted approach to say, right, here are the top 5 assets, for example, that have the highest propensity to leak. So let's go target them. Let's go scan these ones first. And then hopefully we will find the issue within those first 5. If not, we can readjust the model and then tackle the next 5 and the next 5. So it's much more of a kind of targeted approach rather than a blanket search. Through the process, the validate and correct, it's also improving your data holding. So though improving your data holding for this particular example here is vital because you can make the best decisions and kind of pinpoint where your team should start, that data can also be used in other processes, consuming to your other systems, enhancing the decision making of those processes. And as I say, it improves the overall process because it's got you are in control because you own the solution. You can readjust the model. It's consistent because it's encoded, so those rules won't change with opinions. They will be a set standard that your data has to meet, and it can be driven to be compliant for your business. So focusing in on water now before we look at the kind of technology used in the solution itself. So water is one of the most precious resources. We need it to survive. However, Water UK estimate that between April 2018 and May this year, over 3 million litres of water was lost from the UK water networks each day, which is an astonishing amount. And the effect of that, significant impact on the environment. The EA are constantly throwing out fines for impacts upon the environment. Loss of supply, again, can have significant impact, either through financial costs imposed by the regulator or compensational claims. And the failure to control this is one example we've got is a couple of years ago, Thames were issued with an over £20 million fine for leaks of untreated sewage into the Thames and its tributaries, which has the social impact of the people that may use that river. They don't want to be swimming around in untreated sewage. It has an impact on the species that may live, so the fish and the other species that may come to drink the water. So the impact of these things are large. So I mentioned we would be talking about our rules-based technology. So we've talked around why it's a problem and why OneSpatial have entered into the space. Now let's talk about how we can apply OneSpatial technology to try and help address some of the issues. So at the core of many of our solutions is our rules engine called OneIntegrate. And the whole process around OneIntegrate is simple. Data in, apply those rules that I was mentioning, and you get data out and reports. And this is a continuous process. So the improved data that comes out on the right can go straight back in on to the left, and you can apply further rules and further enhancements until you have this automated process that is making the reports that are coming out the most accurate and best decision-making tools possible. So here's an example of some interfaces to the data processing. On the left there, it's a kind of validation session. So we're seeing that some of the rules that you applied on the green, yep, they're all good. You don't have to worry about these. But then there are others that have failed. So these are the areas you need to concentrate on. And you can view that either by downloading the data and kind of putting it into your domestic GIS, or you can view the data in our own kind of cache view of the data being processed. And then for reports, these can be either Excel spreadsheets, they can be more formal reports, or we can throw them into graphs and other statistical ways of displaying it, for example, tabular. The interface, so I mentioned that you are in control, this is your system, you can design it, it's quite easy to use. Your system administrator will have access to this interface, and they will be able to design rules and build actions that are compliant for what the business standard is. So it's really, the solution is really trying to put the control and the processing capability into the hands of the utility, trying to drive home that you are being trusted with these commodities. Because you manage the network, so you know the best kind of quality decisions that need to be made. Therefore, let's try and encode that and let that code base grow as people come and go through the utility, and we can save all the information and then grow our understanding of our network, almost like a living network, if you like. And this is what you might get out of the other end. This might be on your desktop, it could be on your mobile, that we'll talk about next. So this is just a screenshot of something taken from kind of the GIS demonstrator that we've got here. And in here, it shows kind of the propensity of a series of pipes to leak from green. You don't need to worry about it. It's not at a high propensity of leaking, all the way down to red. So the red bits would be where your engineers might want to focus. But as this would be a desktop application, they may go, well, there's quite a lot of red there, so maybe we need to slim it down. And this would be where that kind of added value knowledge, where they go into the previous screen there and say, right, okay, so taking this into account, adding this weighted factor in, really improves the process. And it's very much an iterative process, going and making refinements to improve the decision making and pinpointing where the decision or where the location of the investigation for leakage needs to start. So the mobile bit, connecting to mobile. OneSpatial also have technology in this space, and it's called LMap. LMap stands for Location Mobile App Platform, and we've designed this to be very much similar to our approach to kind of data quality, flexible, putting the kind of configuration of it in the most easy to use and kind of task-centric apps as possible. So effectively for non-GIS users. And many of those really clued-in engineers that I mentioned before are not GIS users. They want to get out there, they know what their physical job is, they need to get out and let's say they need to replace a section of pipe. But the business demands that they record and make a digital copy of their kind of activities out in the field. So we want to make this as simple, as much as a driven process as possible. It also places quality at its core. So we've actually kind of micro-sized the rules engine that we saw before that would traditionally sit on your server, and we've plugged it into this to LMap as a mobile tool, meaning that rules and actions can be driven and run in an offline and online state. So as I'm capturing information, those kind of quality data standards that we've kind of implemented in-house are also being, in an automatic fashion, kind of implemented at a field base as well. And key there is that it runs offline. So if I'm offline, if I'm in the middle of a kind of broadband blind spot, but I'm still capturing information, the engineer is not hampered by that. He's still able to capture that information, and the quality of the data is at the standard expected by the business. And the rules engine there is to help him do that. So the components, I mentioned before that we try and keep ourselves as data and kind of technology agnostic as possible. So the view on our mobile app that we'll see kind of a demonstration of later, we try to keep it open source, exploring Mapzen and Mapbox. However, because the system is flexible, it can be easily configured to consume almost anything. As I mentioned, with the rules engine's got a plug-in there, so we can run rules in offline and online capability. It's got editing functionality through OneEdit. It's got a search capability, so depending on your kind of data structure, we can configure the search to search for pretty much whatever you like, your asset ID, a location or a road, whatever it might be. Data sets that we've explored, so obviously we've got the small world in there, that we can't go far from talking about geospatial and Esri. We've also got our GeoCortex in there and GeoServer, so compatible with open source. And then we've also got kind of capability to integrate with job managers. So SAP is a big one at the moment, integrating with the SAP Job Manager. Or as an example we've done with a utility, we've actually made the GeoCortex the Job Manager. So jobs can be organized through GeoCortex and then passed into LMap as kind of a scheduling tool. The app itself, we built it on the kind of 70-30 approach. So 70% of the app is there, it's done, it's ready to go. If you wanted a very simple app deploying, we would just say, okay, well, the SDK is majority done, and we'd be able to spin up an app suitable for a viewing, maybe a search within a matter of weeks rather than a typical over a month time frame. And some examples that we've kind of explored is like asset management tools, cutoff, so loss of supply simulations, incident management, replacement programs, all of this, very targeted single-use applications that enable field users to get out there and effectively do their job in a quick and efficient manner, while also being able to provide those at the desktop who are making the kind of analytical decisions based off the information captured, their job easier because they can trust the information that's being captured in the field, because they know that the engineer would have done his best job while capturing it, but also the rules are there to just make sure that any missing bits are captured in an accurate and conformant manner too. So this is just an example of the mobile application. We've got a short demonstrator coming up. So this is, I'm offline, I'm online, doesn't particularly matter. And what we saw before in the desktop visualization, we then can see in mobile. So connecting desktop users to field users in a near real-time process, meaning that when the field user needs to contact the office and say, oh, I've investigated the asset and given the asset number on Lodge Lane, let's say, and it's not here. That means that the desktop user can then have a look at his system and go, oh, okay, so it's not there. Maybe we need to go back and recalibrate the model and provide new information. And as with any kind of GIS, though it's targeted, the functionality of your stereotypical GIS is there. So we're able to kind of interrogate features, look at attribution assigned to those features, edit them, those attributes if needed, giving the engineer kind of the capability to make field decisions as well. All right, demonstration time. So I just need to, I'm doing this on a tablet in Cambridge, so I just need to connect to my tablet. Hopefully you will all be able to still see the screen. Oh, bear with, we're just connecting. Right, hopefully. Are you guys able to see the tablet view? Should be a map with a job on the left.
Yeah.
Yes, perfect, nice one. So this is LMap, and as I say, it's targeted to a very kind of specific use. In this case, it's leakage. So on the left there, we've got kind of a job scheduler. So as I say, we've integrated with a job manager, and this is a job that's been allocated to me as an engineer. So it's been said, right, go to Tom, and this is the job. So I can simply go to site and go, right, okay, where do I begin with the assets that I've been allocated? And that's instant load from the view of the desktop. So I'm seeing what the desktop users have kind of through their analytics produced. So it's no longer go to this DMA and do some scanning. It's okay, I can see what they see. And instantly you can say, okay, so this one is standing out as red. Maybe I need to start my investigation on this asset. But then I can also say, all right, what other factors can contribute here? So we've got a little active layer section here where we've broken down some of the kind of factors that we've laid in and said, okay, this is the total. So, but I'm aware of the one on Hunter's Grove. That's standing out at the moment. Let's have a look at material. So what material? What factors or what weighted factors material? Oh, okay. So I can see that maybe the ones on the left are slightly older infrastructure. Hunter's Grove, the one up there, is still red. So I can say, okay, so that might be contributing to where I start. But there's other ones further down here that were kind of orange that are now green. So I could suggest maybe they've been replaced with plastic. So maybe that's not the best place to start. But let's do some further investigations. Let's look at burst history. So now we can say, oh, actually, burst history, a lot of these materials, a lot of these pipes are actually doing okay. However, the one at Hunter's Grove is still not scoring a green. So that's an area of concern. But it might be that, it was poorly installed a short while ago. So let's look at age. Let's see if it was installed recently. But no, again, it's failed. It's gone red. So as a field engineer, I can have advice from a desktop analyst saying start at this DMA, this area, but I can also make my own decisions. Well, I'm going to go and start on this asset, which I can select and say, okay, I've got all the attribution I need. And I might start my investigation there because on 3 factors, 4 if you include total, it's flagged as a concern. So that might be a point of me saying, okay, I need to indicate that I need to go there. And I've got an option on the left here, so I can add some notes that I can send off and say, right, be aware of this. And I've got some kind of icons that I can put in, so I can say, right, I'm going to start there. There's also a search functionality. So if I go to, I've opened up my application, I've opened up my job, and the desktop analyst has said, right, I know for a fact that I am concerned about the asset on Lodge Lane. So I can go into my search and I can search for my Lodge Lane. And it will bring back several assets and the roads. So I'm able to click on whichever asset I deem worthy or the highways, and it will take me straight to it. So I go, right, okay, that's been indicated to me by the desktop or my desktop analyst. as a real concern because of maybe factors that we haven't integrated into the kind of GI system. Maybe there's something on their kind of SCADA system or on their SAP system, or maybe from other analysis. So they may have got a phone call from a developer or another utility who may ring up and go, oh, hi guys, we're working on Lodge Lane and we've accidentally struck one of your assets. You need to come out and come and fix it. So that's the allocation of a job. But it may be that these processes are more reactive. So when I allocate a job, that's me trying to either tackle an issue that's happened or trying to use, as part of our kind of capital replacement program, a way of predicting which assets fail. So get out and fix it before it happens. But it may be that it's more reactive. It may be that the guys in the field, they've just had a report that there is sewage flowing into someone's front garden. I need to go out and fix it. So the engineer who's in the area can allocate himself his own job. So you can get the little plus button and go, right, okay. And I'm going out because there's a leak. And it's a sewerage event. I'll just call it task. And I can create my own job. Once I've created my own job, because I've kind of pulled it down off the server, I'll have to download that job, so it's not really available for me. But assuming that the kind of information that we've downloaded is available, that download's pretty quick. Now it could be also that there's a telecommunications issue in the area, and all of a sudden I lose signal. So in a telecommunications strike simulation, suddenly I'm offline. But that's not a problem. So it says at the top there that I'm working offline. Oh, okay. I did go offline, but it seemed to stop sharing my my Bluetooth. I'll come back online now. Just bear with me. Okay, you should be able to see my screen again. So I created my leakage demo too, and what I did is I went offline. It looks like every time I go offline, it also turns off my Bluetooth, so I can't communicate with my laptop. But we'll see how this goes. So we're still working offline. You can see at the top there's a little tab saying working offline. You'll have to forgive me if the Bluetooth drops out again. But here we are. I've got no signal, and I've still got the same accessibility. I've still got the same kind of functionality as I have as if I was working online. Okay, so that's the demo. Let me see if I can just switch back now. Okay. Hopefully that was useful. Is there any questions? Any hands raised? Doesn't look like it. Oh, is that are they question marks?
Deborah.
Okay.
Deborah, you're off mute, so you can ask your question. Deborah?
Are you still there, Deborah? Is it Daily?
Okay.
Oh, my volume's up. I can't hear her.
Deborah, if you do still have a question, we can't seem to hear anything, but if you do, then maybe you can write it in the questions box. Does anyone else have any questions? Mark?
Hi, can you hear me?
Hi, Mark. We can hear you. Yeah.
Yeah. So I was just wondering what platform this is built on. I was just wondering if it's kind of bespoke, sort of in-house, or whether you're using something like FME server or something behind the hood.
So the One Integrate engine is kind of our in-house, but it's a product, so it's kind of off the shelf. The LMap is actually built on Xamarin, so it's open source. Right. We try to keep it as platform agnostic and compatible with as many things as possible.
Okay. And is it like a hosted solution or something that you would expect to be on-premise?
The answer to that is either. Obviously, you would have to deploy it onto your tablets if you wanted the mobile element, but it can be hosted or in-premise, whatever the utility is most comfortable with.
Okay.
Perfect, thank you.
No questions from Deborah. So. Okay,
perfect. Well, thanks for coming, everyone. If you've got any further questions, my email is on screen there, so please don't be afraid to drop me an email or give me a call, and I will answer with what I can. Thanks for your time, and hope you join us in, I think, a week's time for the asset inference webinar. Thank you. Bye.